Here's another example of an accumulation problem. The last one was trig. This one is a combination of trig and a piecewise function, so let's dive into it. A, how many cubic feet of snow have accumulated on the driveway? Again, anytime you see that word accumulation, you should think integral because you're accumulating. It says in the problem, it accumulates at a rate modeled by this function, so you need to set it up by 6 a.m. So we're talking about the integral from 0 to 6, 0 is midnight, 6 a.m. of f of t. Again, don't waste time writing down the function. Just write down the function notation. Yes, make sure you're in the habit of putting the dt. I really don't think they're going to count off for that, but it's better to be safe than sorry. That's 1 point just for setting that up. Get your calculator active, so then don't try and integrate that by hand. You can't integrate that by hand, okay? You do have to rely upon your calculator here to integrate the function 7. We use x's instead of t's. E to the cosine of x. Make sure you close your parentheses in all the proper places. Comma x, comma lower bound 0, comma upper bound 6. Close your parentheses. Give it time to think. And it is 142.274 cubic feet. You get 1 point for the integral, 1 point for the answer. Okay. B, find the rate of change of the volume of snow on the driveway at 8 a.m. Find the rate of change of the volume of snow on the driveway at 8 a.m. So we've got two things going on here. Just like in the last problem, we had two things going on. We had gravel coming in, we had gravel being processed. Same thing here. Snow is falling, it's accumulating, and it's being removed. So we've got the, let's see here, it wants the rate of change of the volume. Okay, so we've got rates right here. We have rates. F of t is a rate. So what's the rate at time 8 for the rate at which it's accumulating minus the rate which is being removed, g of 8. So f of 8, you plug it into your calculator to get that value. G of 8, 8 falls within this last interval there. Okay, 8 is between 7 and 9. So find f of 8 in your calculator, subtract 108 from that, and you get negative 59.582. This is just a 1-pointer for the answer. Okay, they're really not looking for anything but the answer. But the key here is it says find the rate of change of the volume of the snow. Well, you have the rate for the accumulation, you have the rate at which it's being removed. So accumulate minus removal gives you the rate of change of the volume, total volume. All right, so let's look at C. Let H of T represent the total amount of snow in cubic feet that Janet has removed from the driveway at time T hours after midnight. Express H as a piecewise defined function with domain. So we're trying to find the total amount of snow. We know what she is removing, okay? So let's start at 0, okay? Let's start at 0. H of 0 is 0. She hasn't removed any snow. She's not removing any snow to begin with. So then H of, well, we'll break it into the same intervals that the original problem did, from 0 to 6. Okay, from 0 to 6, H of t looks like this. It's H of 0 plus the integral from 0 to t of our g of s. Remember yesterday we changed the variables there. We changed the variables because you can't have the same variable in your expression as you do as a limit, okay? So we've got what we started with plus the accumulation from 0 to t, which equals h of 0 is 0, and that rate is 0 on this interval. So that's just going to end up giving us 0. Okay, between 6 and, that shouldn't have an equal to. Between 6 and 7, sorry, I'm having to look at another paper here. Between 6 and 7, we've got h of t is equal to, we start at 6, h of 6, plus the integral from 6 to t of g of s ds. Okay, h of 6 is still 0, okay, because she still hasn't removed any. She starts removing at 6 a.m., so she hasn't removed any at 6 a.m. Plus the integral from 6 to t between 6 and 7, the rate is 125. So if we integrate that, that's 125t from 6, or 125s from 6 to t. So that's 125 times t minus 125 times 6. Now, if you'll notice on the answer key, they go ahead and just write that. They factor out the 125. Okay, and then between 7 and 9, we've got h of t is equal to h of, we start with 7, plus the integral from 7 to t of g of s ds. Now, h of 7, that's not 0 anymore, okay? She removed for 1 hour at a rate of 125 cubic feet. So she's removed 125 cubic feet. From 7 to t of, and then this rate changes to 108. So when we integrate that, that's 108t, nope, that should be an s, with respect to s, from 7 to t. So that equals 125 plus 108t minus 108 times 7, which you can do the exact same thing that you just did on the last part. You can factor out the 108. And they're good with a function like that. Now, technically, they did say to arrange it as a piecewise function. You're working all that out. So you do need to finally, kind of give the final answer here with everything all cleaned up. We'll just go h of t is equal to, the first one was 0. 0 when t is between 0 and 6. It was 125 times t minus 6 for 6 to 7. I keep on wanting to put that equal sign right there. And then it was 125 plus 108 t minus 7. When it's between 7, and I did it again, when it's between 7 and 9. So they give you 1 point for each of those. 1, 1, and 1. So we are up to 6 points now. That leaves us with 3 points for the last part. So let's go ahead and look at the last part there. The last part says, how many cubic feet of snow are on the driveway at 9 a.m.? Well, this goes directly from part C. Okay. Partially from part C. Okay. Part C gave us, what did part C give us? Part C gave us the total amount of snow that's been removed. So we need to take, if we want to find out how much snow is on the driveway at 9 a.m., we need to accumulate between 0 and 9 of our function that is accumulating the snow. Okay, the f of t, that's the rate at which the snow is falling. And we need to subtract h of 9 because h gives us the amount that she has removed at the 9th hour. We don't need to accumulate that. We've already done that. We already did the accumulation part. H just gives us how much she has removed at a certain time. So we can just subtract H of 9. When we do that, this is calculator right here, and then this would be plugging it in to this last piece. You get 26.334 cubic feet. So you get 1 point for the integral, 1 point for including the H of 9, and you get 1 point for your final answer. It didn't say include units, but always just be on the safe side and include units.